Coming up on How Do They Do It? How do they use explosive rockets to catch planes in midair? We show you on How Do They Do It? Flying just isn't natural, at least not for humans. It takes a combination of forces working together to keep planes airborne. However, if something goes wrong, it only takes one force to bring them down: gravity. But engineers at Ballistic Recovery Systems have developed a way to glide planes to safety, not only saving lives, but the plane as well. So, how do they do it? There have been accounts of parachutes on record as far back as the 9th century. However, it was Jean-Pierre Blanchard in the 18th century that demonstrated its use as a life-saving device. Over the years, parachutes have saved countless lives, but there hasn't been a way to save the plane. The first problem is size. To slow the descent of a person, you normally need a 100-foot parachute. So to carry even a small aircraft, you need a massive parachute. And one that large is incredibly bulky and heavy. You could just about get them on a plane, but then there'd be barely any room left for the pilot and passengers. That's why aviation experts said it couldn't be done. But then one day, pilot Boris Popov found himself in a plane which was falling out of the sky.
All the way down, I went through the various phases of denial and anger and everything else, but the most poignant memory I have was being just angry that I didn't have some sort of a parachute device. Something that I could do to save my life at this point.
Having cheated death, Popov set out to do what couldn't be done and create the first airplane parachute. To see how he did it, we've come to Ballistic Recovery Systems on the outskirts of St. Paul, Minnesota. This is the birthplace of Popov's revolutionary aircraft parachute system. But these are unlike any parachutes you've seen before. Popov realized you would need a massive chute to save an airplane. This one is 1,000 square feet. But a chute that size made from normal parachute nylon would weigh as much as a small plane. So here they use a super strong, lightweight composite. And they make the strings out of a special kind of nylon, 5 times tougher than steel, but 100 times lighter. The result is a 1,000 square foot parachute weighing just 30 pounds. The next problem is bulk. You can't strap a parachute pack the size of an elephant onto the back of an airplane. So the engineers devised a folding technique to minimize the amount of space the parachute uses. And then they use a massive hydraulic press to compact the chute. Under a force of more than 11 tons, the folded chute becomes as dense as a block of wood. But getting the giant chute to unravel quickly was a major challenge. The longer it takes to deploy, the less time there is to decelerate the plane.
Make it small, make it light, but you better get it out quickly.
Unless he could get it to deploy quickly, Popov knew his parachute idea was not going to work. So he came up with the idea to blow them open with rockets. He tested his rocket-launched chute idea using trucks and hang gliders, and after a few failed attempts, he cracked it. These custom-made rocket motors are assembled very carefully here at BRS. 2 linked electrical detonators are placed in the base of the rocket, and then a 1-pound explosive charge is added. But the rocket-fueled deployment revealed another problem: the speed of the plane. If the chute opened too quickly, it would give the airplane such a jolt, the parachute itself could rip the plane apart.
One of the primary engineering challenges that we had was, how do you make a parachute that's going to deploy at 150 miles an hour but also deploy at 40 miles an hour.
The ingenious solution is the slider. A simple ring of fabric that prevents the chute from opening fully at the start, but which then slides down, allowing it to open wider and wider as the plane slows. So the parachute, complete with slider, is packed into a specially designed bag and sent off with its rockets to be attached to the aircraft. This is Cirrus in Duluth, Minnesota. They are the first aircraft manufacturer in the world to install Popov's revolutionary airplane parachutes as a standard. But you can't just throw the parachute on top. It needs to be mounted in such a way that when it deploys, the plane remains intact. So when the rockets fire, they push out a 5-foot-thick fiberglass panel without doing any damage to the rest of the plane. The nylon straps are built into the body of the plane, which smash through the sides on deployment. Loading the explosive at the airfield is extremely dangerous, so the rockets are armed here at the Cirrus factory. From here on, the rockets are ready to fire and have to be handled with extreme care. So a specially trained technician is called in to install the rocket motor.
The first time I did this, it was scary. Just one little slip and it could go off. You pull that pin and it could go off.
As long as everyone obeys the safety rules, they go on just fine. More than 30,000 BRS parachutes are now flying on light aircraft throughout the world. And they've already caught over 200 different planes, saving hundreds of pilots and passengers from almost certain death.
Well, you know, I'm humbly proud. And take an ID off of a napkin at a coffee shop and end up saving today 230 lives. That's a privilege and an honor for me.
Now that the technology is in place, he believes before long it will be available for commercial aircrafts.